So, we are going to commence on a journey which will, in a certain sense, ensconce our foundation with mathematics, something that is going to help us in general, not only towards our +2 preparation, but not only towards a competitive exam preparation, but for the health of the subject at large. How I'm going to start the whole thing is with a bunch of tools. When I talk of tools, it's more about notation that I'm going to communicate to you. And in my series or sequence of notations that I'm going to impart to you, the first one that I'm going to impart to you would be what's referred to as the modulus notation. Now, all of you understand what the real number line is. You know what the real number line is? The real number line is this. It has an origin that represents the number 0, right? And then to the right of the origin, you encounter all positive real numbers. To the left of the origin, you encounter all the negative real numbers, right? So you have, in a certain sense, to the right of the origin, numbers like between 0 and 1, you encounter all numbers between 1 and 2. So it's all real numbers, not just integers, but these integers are only benchmarks along the real number line, right? And then on the negative side, you have -1, -2, -3, -4, and so on and so forth. That's the real number line, right? Now, along the real number line, there could be any number, x. There could be any number, x, say. Say, x, for example, could be a number like 1.5. Say, for example, x is 1.5. It will lie somewhere between 1 and 2, right? Now, we define a notation, which means the distance of x from the origin. Modulus x is a notation. This is, with around x, you have two parallel bars, right? And this is referred to as modulus of x, or modulus x, or mod x. Sometimes we just call it mod x. What it means is, if x is any real number, which could be located on the real number line, mod x means distance of x from the origin. Mod x means distance of x from the origin. This notation stands for distance of x from the origin. Right? Now, so if x is 1.5, how far is it from the origin? 1.5 units, isn't it? So if x is 1.5, for example, then mod x means what? Distance of 1.5 from the origin. What's the distance of 1.5 from the origin? 1.5 units, 1.5 units. Right? Suppose x is minus 3.2, minus say 2.3. Minus 2.3 would be a number somewhere here, isn't it? Between -2 and -3 would lie a number minus 2.3, right? Minus 2.3. Now, how far is minus 2.3 from the origin? 2.3 units, isn't it? 2.3 units. So if I had x is minus 2.3, which is obviously to the left of the origin, right? Then mod x means distance of x from the origin, which is mod of minus 2.3. Distance of minus 2.3 from the origin is how much? 2.3 units. 2.3 units. Yes or no? Suppose x is 0. Then mod x means mod of 0. Means distance of 0 from the origin. How far is 0 from the origin? 0 units. So mod of 0 is going to be 0. Yes or no? Right? Now, do you realize that this modulus is an operation? It acts on a number x. And what's the output that it produces? Distance of x from the origin. The output produced by mod x is distance of x from the origin. And therefore, it can never be negative, because distance can never be negative. Mod x means distance of x from the origin. And it can never be a negative number. So mod x produces an output, mod x produces an output that can never be negative. It produces an output that can never be negative. Yes or no? Right? It can be 0. It can be all positive numbers, but it cannot be any negative real number. Yes or no? So mod x, what does it stand for? It means distance of x from the origin. Right? And the output that it produces is non-negative. 0 or positive numbers are non-negative numbers. Right? It can never produce a negative output. Yes or no? Right? Now, having said this, say if I said mod of x is 5. X is not known, but mod of x is known. X is not known, but mod of x is known. What does it mean? X is some real number whose distance from the origin is 5 units. Whose distance from the origin is 5 units. Very clearly, if this is 0, there is a number 5 to the right of the origin, and there is a number minus 5 to the left of the origin. What's the distance of 5 from the origin? 5. What's the distance of minus 5 from the origin? 5. Yes or no? That means mod x is 5 is about all those numbers x, all those real numbers x, whose distance from the origin is 5 units. What are those numbers? Plus 5 and minus 5. So if mod x is 5, it means distance of x from the origin is 5. So x could have been either plus 5 or minus 5. Yes or no? If mod x is 5, x could be plus 5 or minus 5. When somebody says mod x is 5, he's saying x is such that its distance from the origin is 5 units. Find x. Obviously, there could be two values of x, plus 5 and minus 5. Yes or no? Make sense to all of you? Now, if somebody said mod x is 2.3, what is x? Plus or minus 2.3. Mod x is 2.3 means distance of x from the origin is 2.3 units. Mod x equal to 2.3, read it in normal language. Distance of x from the origin. What does this mean? Distance of x from the origin. That's 2.3 units. That means x could be either plus 2.3 or x could be minus 2.3. So x could be plus 2.3 or minus 2.3. Yes or no? If somebody said mod x is minus 1, what is x? If somebody said mod x is minus 1, what's x? Nothing. Because mod x cannot be negative. Mod x can never be a negative real number. Yes or no? So mod x equal to minus 1 will not give you any value of x. Will not give you any real value of x. So this is not possible. No real value of x will give you mod x equal to minus 1 or any negative real number. Not possible. If mod x is 0, what does it mean? What is x? X can be 0. There is only one real number who's 0 units away from the origin, that is 0 itself. So mod x is 0 means x is 0. Yes or no? Right? So if I had mod x is a, where a is a non-negative real number, because the output of this operation can never be negative. So a cannot be a negative number. A has to be greater than or equal to 0. Yes or no? Mod x is a. Then what can you say about x? X can be plus a or minus a, isn't it? Mod x equal to a means x is a number such that its distance from the origin, mod x means distance from the origin is a units. Obviously, a number a will be a units away from the origin. A number minus a would also be a units away from the origin. So if x is a, then also mod x will be a. If x is minus a, then also mod x would be a. Yes or no? So mod x equal to a would mean that x can be plus or minus a. But a cannot be a negative number because the output of this operation can never be negative. Yes or no? Sounds good? No confusion? So, now I'll ask you to obtain the values of x such that mod x is 4, mod x is minus 2, mod x is 3.1. What would it mean mod x is 4? X can be plus 4 or minus 4. Why? Because mod x equal to 4 means x is such that its distance from the origin is 4 units. Obviously, there are two numbers, x equal to plus 4 and x equal to minus 4. Both are 4 units away from the origin. So, mod x equal to 4 means x can be either plus 4 or minus 4. Mod x is minus 2? Not possible. Distance of x from the origin equal to minus 2 is rubbish. It's not possible, right? So, this is not possible. The output of a modulus operation can never be negative, Mod x is 3.1. X is 3.1 units away from the origin. Obviously, and minus 3.1. This would mean x can be plus 3.1 and minus 3.1. Yes or no? Right? Very clearly, I have a number 3.1 and I have a number minus 3.1. Both are 3.1 units away from the origin. So if somebody said mod x is 3.1, there are two permissible values of x. X can be plus 3.1 or minus 3.1. Yes or no? Do you understand this? No confusion? Now, suppose I told you mod x is less than 2. X is such that, what is the left hand side? Distance of x from the origin. Mod x means distance from the x from the origin. Mod x less than 2. And I inquired, what are the permissible values of x? I inquired, what are the permissible values of x such that distance of x from the origin is less than 2. What you do here is, this is the origin. X equal to 2 will lie somewhere here. X equal to minus 2 will lie somewhere here. Right? Now, if x floats anywhere between 0 and 2, do you realize its distance from the origin will be less than 2? Because this is 2 units. Mod x would mean this distance. Yes or no? Mod x would mean this distance. If x is this number, mod x would mean this distance. Right? So, x can lie anywhere between 0 and 2. Yes or no? If x floats anywhere between 0 and 2, its distance from the origin will be less than 2. Are you confused? No. Now, if x is somewhere here between 0 and minus 2, right? Then its distance from the origin would be this length. Geometrically, mod x would be this length. Mod x would be this length. And do you realize this length is less than 2 units? That means x can also lie between minus 2 and 0. Yes or no? So if x floats between 0 and 2, its distance from the origin is less than 2. That means mod x will be less than 2. If x floats between minus 2 to 0, then also its distance from the origin is less than 2. Yes or no? So if I said mod x less than 2, it means x can float anywhere from minus 2 to plus 2. X can be anywhere between minus 2 to plus 2. Yes or no? Do you all realize this? No confusion now? If mod x less than 2 means, find the values of x for which mod x less than 2. Mod x less than 2 means distance of x from the origin is less than 2. And when would the distance of x from the origin be less than 2? If x lies anywhere between 0 to 2 or minus 2 to 0. That means x could float anywhere from minus 2 to 2. Yes or no? Right? So if I said mod x less than 5.6, that means distance of x from the origin does not exceed 5.6 units. What are the permissible values of x? To 5.6. Okay, let's read this statement. Mod x less than 5.6 means distance of x from the origin is less than 5.6 units. Distance of x from the origin is less than 5.6 units, right? Mark this 0. This is 5.6. This is a number 5.6 here. This is a number minus 5.6 here, right? Now if x lies somewhere here, then this length represents modulus of x, distance of x from the origin, right? And do you realize this number, this length is less than 5.6? That means x could float anywhere from 0 to 5.6. If x lies here, then this length will represent mod x. This length will represent mod x. Then also distance of x from the origin, which is mod x, is less than 5.6 units. Yes or no? Do you see that graphically? Geometrically you understand this fact, right? That means mod x less than 5.6 means x could float anywhere from minus 5.6 to plus 5.6. Yes or no? Right? So x could float anywhere from minus 5.6 to plus 5.6. Yes or no? Does it make sense to you? No? Confused? Where? What's the confusion?
Putting the value of x in 0 to f in minus negative 12, then the distance from the origin of x is minus 5.6.
No, distance is not minus 5.6. Distance is 5.6. This length is 5.6 units. This length is 5.6 units. Right? And do you realize this length is less than 5.6 units? No? Is this length not less than this length? This length is 5.6 units. Is this length less than 5.6? No, it is less than 5.6. How can this length be more than this length? This length is obviously less than 5.6. No? Suppose OP, this is OA. Which is more? OP is more or OA is more? OP is more, na? OA is mod x. Distance of x from the origin is mod x. This length is mod x. And this is 5.6 units. So if x lies somewhere here, then its distance from the origin will be less than 5.6 units, isn't it? You still confused? No? So if mod x less than 5.6, it means distance of x from the origin is less than 5.6 units. And if the distance of x from the origin is less than 5.6 units, obviously x cannot be to the right of 5.6. Because if x were to be to the right of 5.6, its distance from the origin will exceed 5.6 units. Obviously it cannot also be to the left of minus 5.6. If it were to be to the left of minus 5.6, then the distance of x from the origin will exceed 5.6 units. So x has to float between minus 5.6 to plus 5.6 if mod x is less than 5.6. Yes or no? Are you clear about this? In a very general sense then, if mod x is less than a obviously is a number greater than or equal to 0. If mod x is less than a, it means distance of x from the origin is less than a. Distance of x from the origin is less than a. This is 0, this is a, this is minus a. So if x lies somewhere here, then distance of x from the origin will be less than a units. If x lies somewhere here, then also the distance of x from the origin is less than a units, right? That means mod x less than a would mean x greater than minus a and less than plus a. Yes or no? Right? So mod x less than a means x must float between minus a to plus a. If somebody said mod x less than or equal to a, then x will be greater than or equal to minus a, less than or equal to a. Yes or no? No confusion, right? So if I said mod x less than or equal to 5, what can you say about x? X must be less than or equal to 5, greater than or equal to minus 5. Because distance of x from the origin is not exceeding 5 units. So x cannot be to the right of 5, x cannot be to the left of minus 5. Yes or no? Are you still confused? Sure about everything that I have said? Right? Now, suppose I said mod x greater than 3. That means, what is mod x? Distance of x from the origin, right? That means x is such that distance of x from the origin is exceeding 3 units. I want to find the values of x. That will satisfy this condition. Mod x greater than 3 means x is such that its distance from the origin is exceeding 3 units, right? There is a number 3 here, and there is a number minus 3 here. Yes or no? Right? X cannot lie between 0 and 3, because if x were to be lying between 0 and 3, then its distance from the origin will become less than 3. But we want the distance of x from the origin to be more than 3 units. X cannot lie between minus 3 and 0, because if that was the case, then distance of x from the origin will become less than 3 units. That means x cannot float between minus 3 to 3. Yes or no? If x were to be to the right of 3, will that be okay? Then distance of x from the origin, mod x, is greater than 3. If x were to be to the left of minus 3, then also okay, because the distance of x from the origin is more than 3 units. That means x could lie to the right of 3, or x could lie to the left of minus 3. Yes or no? If mod x greater than 3, it means x could lie either to the right of 3, then distance of x from the origin will be greater than 3. This means distance of x from the origin, x greater than 3, or x could lie to the left of minus 3, x is less than minus 3. Yes or no? Yes or no? Right? Mod x greater than 3 means x will either be greater than 3 or x would be less than minus 3. This means find the values of x for which mod x greater than 3 means distance of x from the origin is greater than 3. That will happen for x greater than 3 or x less than minus 3. Yes or no? If I said mod x greater than or equal to 3, it would mean x would be either greater than or equal to 3, or x would be less than or equal to minus 3. Yes or no? No confusion now? If I said mod x greater than 11, what can you say about x? Not equal to in this case. Absolutely. This would mean x greater than 11 or x less than minus 11. That means x could be to the right of 11, then its distance from the origin becomes more than 11, or x could be less than minus 11. That means to the left of minus 11, then also its distance from the origin will be greater than 11 units. Yes or no? Right? So mod x greater than 11 would mean x greater than 11 or x less than or equal to minus 11. In a very general sense, if I said mod x greater than a, where a is a non-negative real number, what can I say about x? Greater than a or less than minus a. Yes or no? No confusion? All's fair, all's good? Completely assimilated this basic notation? Right? In a very general sense, how you want to read this? The way you might want to read the whole thing is as follows. If I said mod of something, where something is a real number, if mod of something is 3, then that means distance of that something from the origin is 3 units. That means that something could either be plus 3 or minus 3, right? This would mean that something is, this something, whatever that thing is plus 3 or minus 3. Yes or no? If I said mod of something equals A, where A is a non-negative real number, then this would mean that something could be plus A or minus A. That something could be plus A or minus A. Yes or no? If I said mod of something is less than 4, that means that something must lie between minus 4 to 4. Distance of that something from the origin is less than 4 units. That means it cannot be to the right of 4, that something cannot be to the right of 4, and that something cannot be to the left of minus 4. That means this something is less than 4 and greater than minus 4. Yes or no? Right? If I said mod of something, to generalize matters here, mod of something is less than A, where A is a non-negative real number, then I can say that something less than A and greater than minus A. Any confusion? No? If I said mod of something is greater than 10, suppose. If I said mod of something greater than 10, that means distance of that something is more than 10 units. That means that something must either be to the right of 10 or should be to the left of minus 10. This would mean that something is greater than 10 or that something is less than minus 10. Yes or no? So generalize matters here. If mod of something is greater than A is a non-negative real number, then that something must be right, or that something must be less than minus A. Yes or no? No confusion on this. If there was an equality, then this equality will come here also. Right? So now, mod x equal to 8, mod of x equal to minus 7, mod of x less than 4.5, mod of x greater than 5.8, mod of x minus 1 equal to 6, mod of x minus 2 less than 4, mod of x minus 9 greater than 5. Now have a look at these situations, these 7 situations. Obtain the values of x that will satisfy these conditions, right? All of you work on this. Mod x is 8 means distance of x from the origin is 8. There are two numbers that are 8 units away from the origin. X can be plus 8 or minus 8. So this means x can be plus 8 or minus 8, right? Mod x is minus 7. Distance of x from the origin is minus 7. Is that possible? No, not possible. mod of something less than a. Mod of x less than 4.5. That means distance of x from the origin is less than 4.5 units. So x cannot be to the right of 4.5, x cannot be to the left of minus 4.5. This means x must be less than 4.5 and greater than minus 4.5. Yes or no? Isn't it? Confused? No. Mod x greater than 5.8 means distance of x from the origin is more than 5.8 units. Distance of x from the origin is more than 5.8 units. It means x could lie anywhere to the right of 5.8 or could lie to the left of minus 5.8. So this would mean x greater than 5.8 or x less than minus 5.8. Right? Mod x minus 1 is 6. Now if mod of something is 6, mod of something, call this something, s. If mod of something is 6, means that something can be plus 6 or minus 6. This is mod of something, isn't it? Mod of something is 6. That means that something, in this case, that something is not x but x minus 1. Then that something could be plus 6 or minus 6. Could be plus 6 or minus 6. Isn't it? Now, if this is plus 6, then you transpose 1 on the right hand side, x could be 7. One of the values is 7. Isn't it? If you take this as plus 6, then 6 plus 1, 7 is one of the values of x. If you took this as minus 6, then minus 6 plus 1 will give you minus 5. So x could be 7 or minus 5, yes or no? Now, mod of something less than a. Mod of something less than a. Remember this? Then that something must lie between minus a to plus a, right? Then that something is less than a and greater than minus a. So mod of something is less than a. Then this something is x minus 2, not x in this case, right? Then this something is x minus 2 must be less than 4 and greater than minus 4, yes or no? If mod of something is less than a, then that something must lie between minus a to plus a. Must be greater than minus a but less than a. Yes or no? So what's that something in this case? That something is x minus 2. Mod of something less than 4, it means that something must be less than 4 but greater than minus 4. Yes or no? Now, if you solve this inequality, transpose 2 on this side. 4 plus 2, 6. 4 plus 2, 6. That means x less than 6 greater than, transpose 2 on this side, minus 2, minus 4 plus 2, minus 2. So x greater than minus 2. Yes or no? Do you understand these inequalities? Huh? So, no? Confused? Confused? No? So, for this, the values of x would be minus 2 to plus 6. X must float between minus 2 to plus 6 in order that mod of x minus 2 is less than 4. How about it? Right? Now, if mod of something is greater than a, recall, if mod of something is greater than a, it means that something must be greater than a or less than minus a. Less than minus a. Yes or no? What's that something here? X minus 9. Mod of something greater than a. Mod of something greater than a. That means that something must be greater than 5 or less than minus 5. Yes or no? Right? This means that something x minus 9 must be greater than 5 or x minus 9 must be less than minus 5. Minus 5. Right? Now what would this give me? This will give me x greater than 14. Isn't it? X minus 9 greater than 5. That means transpose 9 on the right hand side. This gives me x greater than 14. Yes or no? Or x minus 9 less than minus 5. Transpose this 9 on the right hand side. This will give me x less than 4. Yes or no? That means either x has to be greater than 14 or x has to be less than 4 in order that mod of x minus 9 is greater than 5. Is there any confusion on this? I'll just to make sure that you understand everything, let me repeat similar problems so that you get hands on. Can I wipe this off? Have you made a note of this? So now try these. Mod of x minus 11 equal to minus 15 to mod of x minus 9 equal to 11 mod of x plus 4 less than 3 mod of x plus 7 greater than 8. Find out the values of x commensurate with them. Mod x minus 11 equal to minus 15 is not possible because modulus of a number can never be negative. Mod of x minus 9 equal to 11 means x minus 9 could be plus 11 or it could be minus 11, both possibilities, right? Minus 11. If x minus 9 is plus 11, this would give me x equal to 20. If x minus 9 is minus 11, it will give me x equal to minus 2. That means for this the two values of x are 20 and minus 2. Now see, when I say mod x less than a, please understand this, mod of something less than a, that means that something can lie between minus a to plus a, and it is not or. In this case mod x less than a means x has to be less than a, but x has to be less than a, it can be anywhere to the left of a, but it has to be greater than minus a. This is the origin, isn't it? Mod x less than a is not just about x being less than a. Simultaneously, along with x being less than a, it has to be also greater than minus a. It has to be greater than minus a. Yes or no? So if I said mod of something is less than 3, mod of x plus 4 is less than 3, it means that something has to be less than 3 but greater than minus 3. Has to be less than 3 and greater than minus 3. And please understand this, it has to be less than 3 but greater than minus 3. That means both conditions have to hold good. Less than 3 and greater than minus 3, no? Then only its distance from the origin does not exceed 3 units. Confused? This would give me x less than minus 1, isn't it? By transposing this, and greater than minus 7. Yes or no? Now, if I said mod x greater than a, mod of something greater than a, then it could be either to the right of a or it could be to the left of minus a. Yes or no? Mod x greater than a means x could be greater than a or x could be less than minus a. Or in this case not simultaneously, isn't it? You can't have x to the right of a and to the left of minus a is not possible. Only one of the two things is possible, isn't it? The state of x could be either to the right of a or to the left of minus a. If x lies here, then its distance from the origin exceeds a units. If x lies here, then also its distance from the origin exceeds a units. That means x could be either to the right of a or to the left of minus a. Or, not and. This time it's or. Right? Because it cannot be simultaneously to the right of a and to the left of minus a is not simultaneously possible. Only one of the two states is permissible and possible. So if I said mod x plus 7 greater than 8, it would mean x plus 7 is either greater than 8 or x plus 7 is less than minus 8. Yes or no? This would mean x greater than 1 or, not and, this time or, x less than minus 15. Yes or no? Clear? Perfectly all right? Right? Now, having said this, let me also show you another viewpoint to the same. See, mod of something can never be negative, isn't it? Can never be negative. Mod of something can never be negative. Huh? Now, if I took, say, mod of 3, it means distance of 3 from the origin, that's 3, isn't it? Mod 3 means what? Mod 3 means find the distance of 3 from the origin. What's the answer? 3. And if I said mod of minus 3, it means distance of minus 3 from the origin. That's also 3, right? Yes or no? Now, if this something, if the quantity inside the modulus is positive, the output is the same as the quantity. Do you realize that? If the quantity inside the modulus is positive, then the output of this operation is the same as the quantity inside. But if the quantity inside is negative, then the output of this would be not this, would be negative of this. Yes or no? Minus of minus 3. Do you realize that? If the quantity inside is positive, then the output of this modulus operation is the quantity itself. But if the quantity inside is negative, then the output of this operation is not this quantity, because the output would be negative of this quantity. Do you realize that? That means, can I say mod of something, modulus of something will be the same as something if that something is greater than or equal to 0. If that something is not negative. Mod of something is equal to something if this something is not negative, isn't it? Mod of something will be the same as something provided this something is not negative. The output of this operation would be the same as the quantity inside if the quantity inside is not negative, right? But if the quantity inside is negative, like you see the case here, the quantity inside is negative, the output of this operation cannot be this quantity, would be negative of this quantity. Now if something is negative, then mod of something cannot be something. It has to be minus something. If that something is negative, that is when this something is negative, then the output of this operation cannot be a negative number. It has to be negative of that negative number. But negative of that negative number will be a positive number, isn't it? Right? If something is negative, then minus something will be a positive number. Yes or no? Confused? I know. So, let me go ahead and give you a generalization on this. The generalization is mod of x. X could be a positive or a negative real number. Suppose x is non-negative. Suppose x is non-negative. Then the output of this operation will be x only if x is greater than or equal to 0. Yes or no? But if x is negative, then the output of this operation cannot be x. The output of this operation has to be minus x. Yes or no? Do you realize that? No? No? Not very sure? Mod x will be x if the quantity inside is non-negative. This is non-negative. But if the quantity inside is negative, that means if x is less than 0, then the output of this operation cannot be x. It has to be minus x. Do you realize that if x is less than 0, minus x will be a positive real number? Yes or no? So mod x will be x when x is greater than or equal to 0, will be minus x when x is less than 0. Right? So mod of 10.4, the quantity inside is non-negative, the output of this operation will be 10.4. But if I said minus 10.4, the output of this operation cannot be minus 10.4. It has to be negative of this number. That means minus of minus 10.4, which makes it 10.4. The output of this operation in principle can never be negative. Can never be negative. Right? So this is another way to look at modulus of x. Algebraically, it will be equal to x when x is non-negative and will be minus x when x is negative. In all, it can never be negative. Mod x can never be a negative number. Why? Because graphically, geometrically, it represents distance of x from the origin. Is there any confusion? No qualms? Very good. Now, do you realize if I write mod of x minus 2? Now, x minus 2 could be a positive number or a negative real number. Based on what x is. Right? Based on what x is, mod of x minus 2 could be positive, negative or 0. Do you realize this will be equal to x minus 2 when x minus 2 is greater than or equal to 0? No? But if x minus 2, if the quantity inside is negative, then this the output of this cannot be x minus 2. It has to be negative of x minus 2. It has to be minus of x minus 2. Yes or no? Clear? If x minus 2 is greater than or equal to 0, then the output of this operation will be the quantity inside. But if the quantity inside the modulus is a negative number, then the output of this operation will be negative of that number. And negative of a negative number will still be a positive number. Right? Clear? That means I can write mod of x minus 2 will be x minus 2 when x is greater than or equal to 2? Yes or no? X minus 2 greater than or equal to 0 means x is greater than or equal to 2 and will be equal to, this will become 2 minus x, will be 2 minus x when x is less than 2. Yes or no? Suppose I had mod of 3x minus 1, suppose. This will be 3x minus 1 when 3x minus 1 is greater than or equal to 0 and will be equal to minus of 3x minus 1 when 3x minus 1 is less than 0. Yes or no? This would mean, simplifying further, mod of 3x minus 1 will be equal to 3x minus 1 if 3x is greater than or equal to 1, right? 3x greater than or equal to 1, right? Or x greater than or equal to 1/3, yes or no? But will be equal to minus of 3x minus 1, which is 1 minus 3x. If 3x is less than 1, that is x less than 1/3, yes or no? That means mod of 3x minus 1 will be 3x minus 1 for x greater than or equal to 1/3 and will be 1 minus 3x for x less than 1/3. Yes or no? Why don't all of you do a similar thing for the following? Mod of 8x plus 12. Whatever I did for 3x minus 1, etc., you do for mod of 8x plus 12 to mod of 1 minus 5x mod of 6x minus 2 mod of 11x plus 1. Work on this. So mod of 8x plus 12, you would have realized, will be equal to 8x plus 12 for x greater than or equal to minus 12 by 8, isn't it? And will be equal to minus of 8x plus 12 for x less than minus 12 by 8. Did you get this? Right? Now, 1 minus 5x will be equal to 1 minus 5x for x less than or equal to 1 by 5 and will be equal to 5x minus 1 for x greater than 1 by 5. Did you get this? Mod of 6x minus 2 will be equal to 6x minus 2 for x greater than or equal to 2 by 6, and will be equal to 2 minus 6x for x less than 2 by 6. Did you get this? No? Didn't get this? Number 2? Okay. Mod of 1 minus 5x will be equal to 1 minus 5x if 1 minus 5x is greater than or equal to 0. Right? This would mean, transpose this on this side, 5x less than or equal to 1. Right? 5x on this side. So 5x will be less than or equal to 1, or x would be less than or equal to 1 by 5. Yes or no? And will be equal to negative of this number. That means 5x minus 1 if 1 minus 5x is negative. Isn't it? If the quantity inside is negative, then the mod of this will be negative of this. But what's negative of this? 5x minus 1. That will happen if 1 minus 5x is less than 0. That means x greater than 1 by 5. Isn't it? 5x greater than 1. This will give me 5x greater than 1 or x greater than 1 by 5. Yes or no? See? Mod of 6x minus 2 will be 6x minus 2 for x greater than or equal to 2 by 6, and will be 2 minus 6x for x less than 2 by 6. Did you get this right? Mod of 11x plus 1. Mod of 11x plus 1 will be equal to 11x plus 1 if 11x plus 1 is greater than or equal to 0. That means x greater than or equal to minus 1 by 11. Right? And will be equal to minus of 11x plus 1 if 11x plus 1 is less than 0. That means x less than minus 1 by 11. Yes or no? Is the idea clear? Now, so far so good. Suppose I ask you the following. So, modulus of something. If that something is non-negative, the output is the something itself. But if that something is negative, the output would be negative of that something. Clear? Now, mod of mod x. What do you think that will be? Mod of mod x. See, do you realize mod x is never negative? No. So, this is like mod of something. This is my something. And this something is not negative. That means the output of this operation will be mod x only. No. Mod of something is something if that something is greater than or equal to 0. Yes or no? Now this is what mod of, this is my something. Mod x is something. Yes or no? Mod of mod x. Mod of something. And this something is always non-negative. Mod x can never be negative. So mod of something will be, and since this something is never negative, the output of this outer mod is acting on this, which is a non-negative number. And the output of this operation will be this number itself. Why? Because this number is non-negative. Mod x can never be negative. Do you realize this? No? Confusion? Sure, no? But this in turn will be equal to x if x is greater than or equal to 0, and will be, right, mod x is x when x is greater than or equal to 0, and will be minus x if x is less than 0. Clear? No confusion. If I said mod of x squared, where x is a real number, any real number. Mod of x squared, what would this be? Hey, if x is a real number, x could be positive or negative. But do you realize whether x is positive or negative, x square will always be greater than or equal to 0. X square can never be negative if x is a real number. That means its modulus of a non-negative number. This is non-negative. The output of this will be x square only. Yes or no? Because x square is non-negative. Clear? Huh? No confusion. Mod of x cubed. What would that be? Negative, right. Realize that if x is greater than or equal to 0, then x cube will also be greater than or equal to 0. Then the output of this operation is going to be x cubed itself, right? But if x is less than 0, then x cube would be negative. If x is a negative number, then x cube would be a negative number. Then output of this cannot be x cubed. The output of this will be minus x cubed. Are you comfortable with this? Huh? Right now? Now suppose n is any natural number. X is any natural number. Mod of x to the power 2n. What would that be?
If x greater than or less than 0, then
Realize that x to the power 2n is x power n whole square. Do you realize that? Isn't it? Laws of indices. This is n and 2 will get multiplied. X to power 2n is x power n whole square. Isn't it? Which is always greater than or equal to 0, because square of a real number can never be negative. So x power 2n is always non-negative. So the output of this operation will be x power 2n. Where 2n is an even number. 2n is an even number. So mod of x squared will always be x squared. Mod of x power 4 will always be x power 4. Mod of x power 6 will always be x power 6. Because these are even powers of x and they can never be negative. Yes or no? However, suppose I had see, if n is a natural number, do you realize 2n will be an even number? But 2n plus 1 will always be an odd number. No? Isn't it? 2n will always be an even number, and 1 more than an even number will always be an odd number. Right? So if n is a natural number, 2n plus 1 will always be odd. Now, x cubed, like I said, will be equal to x cubed when x is greater than or equal to 0, and will be minus x cubed when x is less than 0. Right? Mod of x power 5, another odd number. See, when x is greater than or equal to 0, x power 5 will be x power 5. But when x is less than 0, it will be a negative number, so it will be minus x power 5. Mod of x power 7, odd number, will be x power 7 when x is greater than or equal to 0, but will be minus x power 7 when x is less than 0. Yes or no? In a very general sense, mod of x power any odd number, mod of x power any odd number will be equal to x power the odd number when x is odd, when x is greater than or equal to 0, but will be minus of x power odd when x is less than 0. Can I say this? So generalize this matter. Write it formally. I then happen to conclude that mod of x power 2n plus 1, odd number, 2n plus 1 is always an odd number, will be equal to x power 2n plus 1 when, right, and will be minus of x power 2n plus 1 when x is less than 0 precisely. Right. Got me? Can I wipe this off? Make sense? Now, suppose I had mod of x minus 2 plus mod of x minus 3, a quantity like this. Suppose I had a quantity like this. Now think of 3 intervals. 2 and 3. Now when x is less than 2, that means this region, x less than 2 is this region. X minus 2 will be a negative number? Yes or no? When x is less than 2, x minus 2 will be a negative number. So mod of x minus 2, will it be x minus 2? No, it'll be minus of x minus 2. Isn't it? When x is less than 2, x minus 2 is a negative number. And if x minus 2 is a negative number, mod of x minus 2 will be minus of x minus 2. Yes or no? Because x minus 2 is negative, the output of this cannot be x minus 2. The output of this would have to be negative, which is like 2 minus x. Right? Now, when x is less than 2, obviously x is also less than 3. When x is less than 2, I am looking at this case, x less than 2. When x is less than 2, x is obviously less than 3 also. For this case then, x minus 3 will also be a negative number, isn't it? If x is less than 2, x is also less than 3. So x minus 3 would be a negative number. So what would mod of x minus 3 be? Minus of x minus 3, isn't it? Because this quantity is negative. So this will give me 3 minus x. Yes or no? Which means when x is to the left of 2, mod of x minus 2 would be 2 minus x, and mod of x minus 3 will be 3 minus x. Are you all okay with this or not okay? That means this will be 2 minus x plus 3 minus x for x less than 2. How about it? Yes or no? No confusion? Now, when x is lying in this interval, okay, when x is greater than or equal to 2 but less than 3, in this interval, when x is greater than or equal to 2 but less than 3, do you realize in this interval x minus 2 will be greater than or equal to 0? Mod of x minus 2 therefore will be equal to x minus 2. Clear? But x is less than 3. So x minus 3 has to be less than 0. Right? X minus 3 has to be less than 0. So mod of x minus 3, what would that be? Minus of x minus 3, that makes it 3 minus x. Yes or no? That means for x greater than or equal to 2 but less than 3, mod of x minus 2 will be x minus 2, and mod of x minus 3 will be 3 minus x. How much does it turn out to be? 1? Yes or no? Suppose now x is to the right of 3, x greater than or equal to 3. Okay? Are you confused about any of these? No. Suppose x is greater than or equal to 3. If x is greater than or equal to 3, x will also be greater than or equal to 2. So if x is greater than or equal to 3, x minus 2 will be a positive number. Mod of x minus 2 then will be equal to x minus 2. Yes or no? Now, if x is greater than or equal to 3, x minus 3 will be greater than or equal to 0. So mod of x minus 3 will be equal to x minus 3. Yes or no? Confusion? Which means when x is greater than 3 or equal to 3, mod of x minus 2 is equal to x minus 2. And mod of 3 minus x is x minus 3. Right? Which makes it 2x minus 5. That makes it 2x minus 5. This becomes 5 minus 2x. This becomes 5 minus 2x. Do you understand what I've done here? So what really happens is, this 2 and 3 are the nodes. This expression changes behavior at 2 and 3. To the left of 2, it behaves like this. Between 2 and 3, it behaves like this. To the right of 3, it behaves like this. Right? You know? So this expression changes behavior at 2 and 3. And these intervals describe the behavior of this expression commensurate. Are you okay with this? No? Why don't you do a similar thing for, can I wipe this off? Or you want to copy it? Want to copy it? Copy this, and at the same time, whatever I have done for this expression, why don't you do for this x minus 7 plus mod of x minus 15. Whatever I have done for this, break it up into 2 intervals and work around this. Okay? Understand everything that I have said here, and whatever I did for this, do for this. Okay? So you have 2 entities of this kind, right? What you do is, on the real number line, mark 2 points, 7 and 15. Mark 2 points, 7 and 15, which we will refer to as nodes. Nodes of this expression, right? 7 and 15. Alright. So 7 and 15, 2 nodes break the entire real number line into 3 regions, right? To the left of 7 is region 1. Between 7 and 15 is region 2. And to the right of 15 is region 3. Do you understand this? Now we will evaluate this expression in the 3 regions, R1, R2 and R3. Okay? Now, so let me talk of region 1. Region 1 is like x less than 7. That defines region 1? Yes or no? Now when x is less than 7, x minus 7 will be a negative number. When x is less than 7, x minus 7 will be a negative number, right? X minus 7 will be a negative number. When x is less than 7, x is also less than 15. So x minus 15 will also be a negative number. Yes or no? So mod of x minus 7 will, since x minus 7 is negative, mod of x minus 7, will it be x minus 7? It will be 7 minus 7, minus of x minus 7, because x minus 7 is negative. It's going to be 7 minus x, right? Mod of x minus 15. Again, x minus 15 is negative, so mod of a negative number would be negative of this number. So that's going to be 15 minus x. Yes or no? That means for x less than 7, mod of x minus 7 will be 7 minus x. Mod of x minus 15 would be 15 minus x. Yes or no? Right? So that means this expression is going to be, mod of x minus 7 will turn out to be 7 minus x. Right? Mod of x minus 15 will turn out to be 15 minus x for region 1, that is x less than 7. That makes it 22 minus 2x. No? Confused? For x less than 7. Tell me if you understand all that I have said so far. Now, let me look at x greater than or equal to 7. That means now region 2. Region 2. X greater than or equal to 7 but less than 15. Let me call this expression E. Let me call this expression E. X greater than or equal to 7, less than 15 is region 2. Now, when x is greater than or equal to 7, x minus 7 will be greater than or equal to 0. So, mod of x minus 7 will be equal to x minus 7. Yes or no? X minus 15 will be less than 0 in this region. So, what would mod of x minus 15 be? No, if x minus 15, 15 minus x. That means this expression E will be x minus 7 plus 15 minus x. That makes it 8. For which region? For region 2. X greater than or equal to 7 but less than 15. That's region 2. Description of this expression in region 2. Clear? For x greater than or equal to 15. Now I'm talking of region 3. Now very clearly, if x is greater than or equal to 15, this will be non-negative. Isn't it? X minus 7 will also be non-negative if x is greater than or equal to 15. Right? So, the expression E then, since x is greater than or equal to 15, x will also be greater than or equal to 7. So, the quantity inside is non-negative. So, mod of x minus 7 will be x minus 7. Right? X minus 15 will be x minus 15. What do you say? So, that makes it 2x minus 22. So, this expression delivers itself in the 3 regions, x less than 7, which is the 22 minus 2x. It behaves like 8 in region 2, x greater than or equal to 7 less than 15. In region 3, which is x greater than or equal to 15, it behaves like 2x minus 22. Yes or no? Does it make sense to you? Now, just to extend this a little further, can I wipe this off? Are you okay with this now? You still confused? Pakka? Now, suppose you're not tired, right? Suppose I had mod of an expression E defined as mod of x minus 1 plus mod of x minus 2 plus mod of x minus 3. I want a simpler representation of this expression bereft of this modulus sign, right? Now this, the earlier one had 2 nodes, this will have 3 nodes, 1, 2 and 3. 1, 2 and 3. 2 nodes produce 3 regions and 3 nodes will produce 4 regions. This is region 1 to the left of 1. Between 1 and 2 is region 2. Between 2 and 3 is region 3. To the right of 3 is region 4. Yes or no? Now suppose, so I'm going to cause this, I'm going to describe this in all the 4 regions. So region 1 means x less than 1, x less than 1. When x is less than 1, x minus 1 would be negative. When x is less than 1, x minus 1 would be negative. So the output cannot be x minus 1, the output has to be 1 minus x. Plus, when x is less than 1, obviously it's also less than 2. So x minus 2 will also be negative. So the output will be, right, very good, 2 minus x. X is also less than 3? 3 minus x. That means in region 1, that is x less than 1, the description of this is 336 minus 3x. Yes or no? To the left of 1. Now come to region 2. X greater than or equal to 1 but less than 2. This is region 2. Now when x is greater than or equal to 1, x minus 1 would be non-negative. So mod of x minus 1 will be x minus 1. Yes or no? Mod of x minus 1 will be x minus 1 because x is greater than or equal to 1. Then when x lies between 1 and 2, obviously it's less than 2. Obviously x is less than 2. So x minus 2 will be a negative number. So what would mod of x minus 2 be? 2 minus x. 2 minus x. Region 2. Okay. Now, if x is less than 2, x is also less than 3. So x minus 3 will be a negative number? Right. 3 minus x. So how much is it? This is 3 plus 2, 6 minus 1, 5. And then 1x gets cancelled, minus x. Yes or no? Do you realize what I have done? 3 plus 2, 6 minus 1, 5. 1x will get cancelled with this. This x remains. That's region 2. Let's look at the next description. Region 3. Region 3 is x greater than or equal to 2 but less than 3. Now, in this region, when x lies here, x is greater than or equal to 2. So obviously x minus 1 will be positive. The output of this operation would be x minus 1 itself. So x minus 1. Right? X minus 2. X again is greater than or equal to 2. So x minus 2 will be positive. The output of this operation would be x minus 2. But x is right, very good. X is less than 3, so x minus 3 is negative. The output of this operation is going to be 3 minus x. Very good. How much does this turn out to be? This becomes 3 minus 3, 0. And minus x will get cancelled with plus x. You'll have just 1x left. Very good. Excellent. Then x greater than or equal to 3. That's region 4, R4. X greater than or equal to 3. Very good. Now, if x is greater than or equal to 3, x is also greater than 1. So x minus 1 will be a positive number. The output of the output of this operation is going to be x minus 1 plus x minus 2. Very good. Very good. Now you guys got it. And perfect, perfect, perfect. I am convinced now. So that makes it 3x minus 6. Right? So this was a case where there were 3 nodes and 4 regions. And this is the description of that expression E in various regions. Right? 1, 2, 3, we call them nodes because around these points, the the expression changed behavior. It had different looks, right? For this interval, this was the looks of this expression. For this interval, this was the looks. This interval, this interval, this. Do you all understand this properly? So, on your own, you would then want to do a similar thing, right? On your own, you would want to try mod of x minus 1.5 plus mod of x minus 2 plus mod of x minus 5, right? Not now, but this you can work independently, all right?